Question number 34. Two masses M1 and M2 in kg are attached by a massless string. How do you determine tension and acceleration? Assume no friction. Assume M1, M2, and theta, the angle with the horizontal, are known. For convenience, I've also included the parallel component of the gravitational force. W parallel, Wx, is 98 newtons in magnitude. Again, welcome to HDTVEDU.com, direct and simple education in seconds. Good luck. We isolate the mass, all right? We isolate the mass and look at the forces acting on the mass. We are told that M1 is accelerating up the inclined plane. So what does that mean? That means the force up the inclined plane has to be greater than force down the incline. What is force up the inclined plane? The tension. So tension minus force to the right, the bigger force minus small force equals net force. Net force is up the inclined plane. So that means what? The force to the right has to be greater than force to the left. So you say T minus W parallel equals M1A. Bigger force, tension, minus smaller force, W parallel equals M1A. We are given W parallel equal to 98 newtons. We also know what is M1, but we don't know what is A. We don't know what is tension. Net force along the vertical, all right, net force along the vertical is equal to 0. Vertically up, normal force from the surface, and that balances the perpendicular component of the gravitational force. So W perpendicular equals Fn. For the mass M2, what do we have? Again, M2 is accelerating down, right? So you have acceleration down. So that means what? The force down has to be greater than force up. What is the force down? M2G. What is the force up? Tension. So M2G minus T equals M2A. So what did we learn so far? For the mass M1, tension is greater than W parallel, and that equals M1A. For mass M2, gravitational force is greater than tension. So net force is gravitational force minus tension, and that equals M2A. Now you add, and what do we get? T minus W parallel plus M2G minus T equals M1A plus M2A. So we can get rid of tension. 2G minus W parallel equals A times M1 plus M2. So that gives us A equals M2G minus W parallel divided by M1 plus M2. Don't forget, M1 is 20 kg, M2 is 50 kg. G, acceleration, the magnitude of the acceleration due to gravity is 9.8. W parallel equals 98. So you substitute all those numbers, and what do we get? M2 50 times 9.8 minus W parallel 98 divided by 20 plus 50. And that is equal to 5.6 meters per second per second. Why did I write that way? It is acceleration. It's how much your velocity changes every second. So we have a change of 5.6 meters per second. The speed changes by 5.6 meters per second every second. Let's look at the 200 level. At the 200 level, again, isolate mass M1. Isolate mass M1. And look at the forces acting on M1. We have tension to the right. We have M1G sine theta equal to W parallel to the left. This is the parallel component of the gravitational force. Net force equals M1A. So you say T minus M1G sine theta equals M1A. For the mass M2, it is accelerating down. So which force is greater? Gravitational force is greater than tension. So you say M2G minus T equals M2A. So what do we have? T minus W parallel. W parallel is M1G sine 30 equals M1A, and M2G minus T equals M2A. And so when you add, we get M2G minus M1G sine 30 equals M1A plus M2A. So what is A? So you get M2G minus M1G sine 30 equals A times M1 plus M2, or A is equal to M2G minus M1G sine 30 whole thing divided by M1 plus M2. So A equals M2G minus M1G sine 30 over M1 plus M2. Don't forget, M2 is 50 kg, M1 is 20 kg, G 9.8 meters per second. So what do we get for A? M2G 50 times 9.8 minus M1 20 times 9.8 times sine 30. Divided by M1 plus M2, 20 plus 50. So you get 5.6 meters per second Once you have A is equal to 5.6 meters per second, substitute back into equation number 2. Remember that mass M2 is accelerating down, so gravitational force is greater than tension. So you say M2G minus T equals M2A, or T equals M2G minus M2A, or M2 times, M2 is common, times G minus A. G is 9.8, A is 5.6, so you get T is equal to And this is George Mathew signing off. Good luck.